You were crammed into a metal cabinet under 4 square meters, tasked to burn like a machine. In 1896, chemist Wilbur Atwater had volunteers live inside one, 2.1 meters long, 1.2 wide, 1.8 high, for days. He received fixed portions of hamburgers, milk, and mashed potatoes through a small hole. Outside, Atwater carefully analyzed each breath of carbon dioxide and every bit of waste. His goal, to prove the human body was merely a machine. After his thermodynamic experiment, he told the media, energy intake minus expenditure equals stored fat. Obesity or weight loss is simple math. Weight control means managing calories. The calorie concept was not originally Atwater's idea. The concept traces back to the 18th century when Lavoisier, the father of modern chemistry, built an ice calorimeter. He proved that breathing is slow combustion and life's heat comes from food oxidation. The guillotine ended Lavoisier's work, but it failed to prevent calories from becoming a powerful creed that dominates the world. This creed found its most fanatical evangelist in 1918. Dr. Lulu Peters told the public in a fervent tone in her bestseller Diet and Health. To lose weight, we should count calories like money. This unit transformed, leaping from a researcher's calorimeter into everyday life, appearing in fashion magazines, health columns, and countless phones, where it became tied to weight control. The cultural symbolism of desire and strict self-discipline, meant to understand life's burning, became a dogma for controlling life. As Atwater calculated human engine fuel efficiency, another group of scientists was troubled by widespread poisonings. Victims of these diseases consume enough calories, yet are struck by unseen forces. In 1747, sailors on British warships, fed on bacon and biscuits, suffered gum ulcers, bruises, and weakness, as if cursed by the sea. James Lind, the ship's doctor, couldn't bear the sight. He conducted the first controlled trial and identified the culprit. He divided 12 sailors into groups, giving them different remedies: cider, sulfuric acid, vinegar, and seawater. The mixture included barley water, 2 oranges, and a lemon. After just 6 days, while others were still in pain, the pair who ate 2 oranges and a lemon daily regained their strength and could return to work. However, Lind's book, A Treatise on Scurvy, after almost half a century, the British Navy finally mandated lemon juice on ships, consolidating its naval supremacy. Lind's victory marked the triumph of the scientific method over empiricism, though the substance, vitamin C, remained unknown. In late 19th century Asia, a mystery emerged. Beriberi spread among white rice eaters, patients losing weight and depressed. Japanese naval Dr. Kanehiro Takagi suspected diet, adding barley to sailors' rice. Meat consumption curbed the disease. He sensed the direction, but misjudged the cause, blaming protein deficiency. Dutch Dr. Eichmann uncovered the truth when chickens in his lab, fed discarded rice, showed symptoms resembling human beriberi. When he switched the sick chickens to coarse rice, they recovered. Ekman realized the issue wasn't toxins in the rice, but the absence of rice bran in refined rice. This discarded part was the antidote, a discovery in a pathogen-dominated medical field. It caused an upheaval. Diseases can result from deficiency. In 1912, Funk extracted a substance from rice bran, naming it vitamin. Although he didn't extract B1 to treat beriberi, since then, vitamins A, B, C, D have been discovered. Scientists solved these cases one by one. The most dramatic was pellagra, striking poor Europe and America where corn largely prevailed. Patients suffered skin inflammation, diarrhea, and dementia like fading ghosts. American Dr. Goldberg disagreed. In epidemic zones, he tested prison diets, proving pellagra from deficiency. To persuade colleagues, he even swallowed patients' flakes and blood at a conference and was unharmed. He used his body as evidence to prove the real culprit was niacin, vitamin B3 deficiency from a corn diet. As vitamins were discovered, humans seemed to master solving hidden hunger, but soon fell into the quagmire of food surplus. Obesity, diabetes, and heart disease, metabolic illnesses of affluence, became the new enemy. Nutrition shifted from deficiency to excess. Public health responded with dietary guidelines and the nutrition pyramid. Nutrigenomics, guiding society in the age of affluence into the 21st century, draws our attention to the body's subtler aspects. It seeks to answer why one diet doesn't suit everyone. We're beginning to see that nutrients are more than passive fuel. It is a molecule that regulates gene expression. Food can switch genes on or off. Our unique genetic codes, especially single nucleotide polymorphisms, determine nutrient metabolism efficiency. Why are some people insensitive to high-salt diets? Why can't some people tolerate lactose, while others metabolize alcohol well? Such differences are revealed genetically. Nutrition science is shifting from one-size-fits-all advice to precision nutrition based on genetics and microbiome data. From grilling meat by the fire to reporting in front of a gene sequencer, humanity's pursuit of food is a pursuit of existence. We view the human body as a thermodynamic machine, discover vitamins, and now see our unique selves in the genetic map. This exploration has no end, because what really shapes us may not be the food we eat, but the choices we make about eating from generation to generation, between scarcity and abundance, ignorance and exploration.